guys, welcome back to my YouTube channel, especially to my students at North Coast Bohol Institute Incorporated. Welcome back. In this video, we're going to discuss another set of topic in mathematics, which is all about evaluating limit of a function. So the main question here is that how we're going to evaluate the limits of a function. So I have here 4 examples to be evaluated in this video. So in this video, I also assume that you already have knowledge about the theorems, the different theorems on the limit of a function, or how to evaluate the limit of a function. So I have here the first 2 examples to be solved. So we are going to evaluate each of the following here. So the first example is we have this one, and the second is this one. Okay, for the limit of the function, just simply distribute. So let us start already. So for the limit of a function, for number 1, we have limit of a function defined by x squared plus 3x plus 4 as x approaches to 2. So all you have to do, the first thing that you are going to do is to distribute the limit notation to the entire terms, or to each term of the function, which is x squared plus 3x plus 4. So you are going to distribute limit as x approaches to 2 in each term of the function. So let us start. Is equals to the limit approaches to 2 x squared plus limit x approaches to 2 3x plus limit of the constant 4 as x approaches to 2. So that's it. This is what I mean for distributing the limit notation to the entire terms of, or to the entire function, or to every terms in the function. So we have here limit of x squared as x approaches to 2, limit of plus limit of 3x as x approaches to 2, and plus limit of 4 as x approaches to 2. Now after getting this one, you can now have the direct substitution, or we can also have the way of expressing each term into simplest form of the function, or the simplest way of expressing the limit of a function. So we can rewrite this one, limit x squared, into this form, limit of x, so we have here squared, plus 3 limit of x approaches to 2, and plus limit of 4 as x approaches to 2. So we have here, we just follow the theorem on the limit of a function, that the limit of a function with raised to a power should be written in this form, and also the limit of the constant times the function, then you can rewrite that one as the constant times the limit of the function. So we have here now the simplest form of the limit. So as the limit of x as x approaches to 2, just simply substitute limit x with 2, because this is the value where our limit approaches to. So limit of x is equals to 2. Then we have squared here, so just simply square that one, plus 3 times limit of x, so just simply substitute limit of x with 2. So you will get 3 times 2. Okay, plus limit of 4 as x approaches to 2. Since we don't have variable x here, so the limit theorem states that the limit of the constant, or of any constant, is still equals to the constant. Okay, again, limit of the constant is equals to the constant. So you will get limit of 4, limit of the constant 4, that is 4, because the limit of a constant is 4. Okay, so now let us simplify this one to get the exact value. We have 2 squared, that is 4, plus 3 times 2, that is 6, plus 4. Okay, so now we have 4 plus 6, that is 10, plus 4, that is 14. So we have here now the value of the limit defined by limit of the function x squared plus 3x plus 4 as x approaches to 2. So again, the first thing that you're going to do is to distribute the limit notation to each term of the function. The second one is just express each term into the simplest form of writing the limit. So that is why we rewrite x squared in this form. And then after that, just simply substitute the limit notation with a variable or with a function with the value of your x where your limit approaches to. Next, then we have the process of simplifying and then getting the exact value. So this is now how we evaluate the first example. Okay, let's us move to the second example. We have limit of the function x plus 4 times the quantity of square root of 2x plus 5 as x approaches to 2. Again, the first thing that you're going to do here is to distribute the limit notation to each term in the function. So we have here is equals to, so we have to distribute 2. So we have x plus the limit of 4 times limit of the square root of 2x plus 5. So in this case, we have to distribute still the limit notation to the inside expression or to the inside function of the radical sign. So we have to distribute the limit notation. So rewrite x plus limit of 4x approaches to 2. Then we have here times the limit of square root of the limit of 2x as x approaches to 2 plus the limit of the constant 5. Okay, that's it. So we just simply distribute. This symbol stands for multiplication, or you are going to multiply the expression here with the expression here. So now let us continue. So limit of x plus limit of 4 times the square root of the limit of 2x plus limit of the constant 5. So simplify. So limit of x, since this is already in the simplest form, you can substitute limit of x with 2. So you will get 2 plus, again, limit of x, that is 2. Limit of 4, since this is the limit of the constant, so again, limit of a constant is still equal to the constant. So 4 times our square root of limit of 2x, so you can rewrite that one, 2 limit of x plus limit of 5. Don't forget to write x approaches to 2, x approaches to 2. Okay, so let us have another way of simplifying this one. So 2 plus 4 times, we have 2 times limit of x. I'll just directly substitute limit of x with 2. So 2 times 2 plus the limit of the constant 5 as x approaches to 2, that is still equals to the constant which is 5. So this is 5. Okay, this is 5. Here 5, then 5. Okay, so we have limit of the constant 5, we have still equals to 5. Okay, let us simplify. 2 plus 4 times the square root of 2 times 2, that is 4, plus 5, that is 9. So we have here 2 plus 4, that is 6, times square root of 9, that is 3. So you will get 6 times 3, that is 18. So our value of the limit after we evaluated the limit of the function defined by the function, the quantity of x plus 4 times the square root of 2x plus 5 as x approaches to 2 is 18. So this is the way or how we are going to evaluate a limit. Again, the first thing that we are going to do is to distribute the limit notation to the entire terms in the expression. So then, do not forget or do not change the operation here. Since this is multiplication, then at till the end you are going to multiply the two expression. So as you can see here, we multiplied the left side with the right side. Okay, then after that we simplify and get the answer. So we have 18 is the answer. Okay, so let us move for the third example. Okay, so we have here another example. Okay, let me adjust the video recording. It becomes blurred. Okay, so that's it. So we have here evaluate each of the following. So for number 3, we have limit of 4x minus 3 times the quantity of x squared plus 5. So in this case, this is x squared, this one. So we have to distribute the limit notation to each term of the expression. So you will get limit of the function defined as 4x minus 3 times the limit of the function defined by x squared plus 5. Okay, that's it. Now, after distributing this into two expressions which are multiplied, then distribute again the limit notation to each term of the expression or the function. So we have limit of 4x minus the limit of the constant 3 times limit of x squared plus limit of the constant 5 x approaches to 2. Okay, that's it. We just simply distribute the limit notation to each term of the expressions. So we have here limit. We have to rewrite this one to simplest form of the limit notation or limit function. So you can rewrite it one for limit of x as x approaches to 2. Okay, here minus, since this is already in the simplest form, the limit of the constant, so there is no other way of writing that one, so you can rewrite that one as 3, limit of 3 as x approaches to 2 times, we have here limit of x squared, so we can rewrite this one to the simplest form, so we can have limit of x to the power of 2 as x approaches to 2. Okay, so we have plus the limit. So since this is already in the simplest form of a limit, limit of the constant, so we can rewrite that one as limit of 5 as x approaches to 2. Now let us simply directly substitute the value of your, or where your x approaches to the given expression or to the given limit. So we have replace limit of x to where your limit approaches to. So since our limit approaches to 2, or our x approaches to 2, then we can rewrite that one as 4 times limit of x as x approaches to 2. So limit of x, replace that one with 2 or substitute with 2, minus limit of 3. So again, limit of any constant is still the constant, minus 3 times limit x. So substitute limit x with 2. So you can write 2. Then we have squared here, so squared, plus limit of the constant 5, again that is still the constant. So let us proceed. Is equals to 4 times 2, that is 8, minus 3, that is 5, times, this is multiplication symbol, times 2 squared, that is 4, plus 5, that is 9. Okay, again 4 times 2, that is 8, minus 3, that is 5. Then we have 2 squared, that is 4, plus 5, that is 9. So now we have 5 times 9, or we can rewrite it as 5 times 9 is equals to 5 times 9, or 5 times 9 is, we have 45. So our value of the limit after we evaluate the limit of the function defined by 4x minus 3 times the quantity of x squared plus 5 as x approaches to 2 is 45. So that's it. So let us proceed for the last example. We have this one, limit of the function defined by 3x plus 2 all over x squared minus 2x plus 4 as x approaches to 0. So now let us directly again substitute or distribute the limit notation to the entire expression. So you can get limit of 3x plus 2 as x approaches to 0 all over the limit of the function defined by x squared minus 2x plus 4. Okay, so we have as x approaches to 0. Again, we just simply distributed the limit notation to each expression or function given. in the numerator and denominator. So we simply distribute the limit notation to the numerator and denominator of the function. So we have here, after that, we have to distribute again the limit notation to each term of the expression. So just write limit of 3x plus limit of 2 as x approaches to 0, as x approaches to 0. And then the same with the denominator, we have limit of x squared as x approaches to 0 minus limit of 2x as x approaches to 0, and we have plus limit of 4 as x approaches to 0. So that's it. Now, since we don't, since we can still rewrite this one to the simplest way of writing the limit of a certain function, then we can rewrite this one the same with the numerator. So we can rewrite the numerator limit 3 limit of x plus limit of 2. Since this is already the form of a limit of a constant, then we can no longer rewrite that one. So 0 x 0 all over limit of x squared. So we can have limit of x to the power of 2 as x approaches to 0. So again, our purpose here is to rewrite the expression here into simplest way of writing the limit. So we have limit of x squared. This is all the same with limit x squared. So minus, we have 2x here, so we have to move the constant 2 before the limit notation. So x approaches to 0. Now, so we have here plus, since this is the simplest way of writing the constant of a limit, then we can have this one as limit of 4. Still write that one. Okay, so now we have to simply substitute the value or our, as x approaches to 0, so that is the value of our limit x. This is 0. So we have to multiply 3 times 0, because 3 times limit of x, since the value of our limit x is 0, because this is where our x approaches to, so at value of 0. So plus the limit of the constant 2 is still the constant, so we have limit of the constant 2, that is still 2, all over limit of x squared. So the value of limit x is 0, then raised to the power of 2, so 0 squared, then minus 2, the value of our limit x is still 0, so we have 0 plus limit of the constant 4, that is 4. Okay, so we have 3 times 0 plus 2, that is 2. Again, 3 times 0, 0 plus 2, that is 2. 0 squared, 0 minus 2 times 0, 0 plus 4, that will become 4. So we can reduce this one to lowest term. So by 2, you can have 1/2. Okay, so this is now the value of our limit as we evaluate the function, the limit of the function defined by 3x plus 2 all over x squared minus 2x plus 4 as x approaches to 0. So now this is our value. That's all for this video. I hope you learned something from the explanation that I provided, and don't forget to subscribe for more updates to my incoming videos. That's all, and God bless everyone.